And this is your stream health.
Okay, it's live.
Yes.
Sarah's helping me stream for not the first time, but hey, I don't remember things. But it's a new laptop and I had to reinstall the OBS software. So I'm streaming. I'm going to do in Eagle CAD a library part for Spetku here, who needs a connector for her noodle feet board. And so the connector we're going to be using is this connector here. Here, let me go to, where's the component? This connector here. Can I zoom in on the screen if I go? What are they seeing?
I don't know.
Can you look at it? Like, well, I don't, I don't, like, there's no, I need a monitor now. So, anyways, so, oh, this is an image, anyways. Um, so I assume that you can see this Mauser component. So this is a card edge connector, much like the old PCs when you know, or even modern PCs when you build a PC and you slide the add-on boards in. It's the board you're sliding in just has these gold pad finger things on it, and it slides into this connector, which is like a slot or like a Nintendo cartridge looking slot. So Mauser has this connector from Amphenol. It's a newer connector. It's got a really high pitch, so it's a like smaller than what you remember from the 1970s and Atari and Nintendo cartridges. The pins are really small and fine. It's a $4 connector, which isn't a great price, but we're only making one brain for Noodle, so it's a bargain. And so Mauser does give you, if you go through their song and dance, they'll give you some CAD files. I don't know if they have a footprint in Eagle for this. I generally do my own because I trust no one. So I will look at the drawing that I downloaded and I will enter the pads and the outline for this and make a footprint in Eagle so that Sarah can then make a circuit board using that connector. So I'm going to walk through that whole process, and I do this all the time because, like I said, I trust nobody's component. I don't use Eagle's components. I don't use components that I got from a manufacturer because generally they were rushed to get it through, and sometimes they have errors. Sometimes they're just not pretty. And so rather than spend time modifying somebody else's connector, I generally just start from scratch, and I only put the things in it that I need, which is the pads, some silkscreen for the outline, and then in the document layer, the actual what it physically space it takes up, and then in the symbols, I kind of have my own style for doing symbols anymore. Some get really fantastical, and some are just basic, but I don't like other people's symbols or the way they lay out pins or whatever. So I'm going to do all those things the way I do it. And then Sarah later this week is going to use that connector in her circuit board that she's making for Noodle's brain. And that's a piggyback board for the Jetson module, the NVIDIA Jetson computer module. And then she's adding a brain module that's an Arduino thing to run the motors. So, and she will tell you all about that on her stream. So let's get to it. So there's the connector. I found it on Mauser, put it in my shopping cart. I downloaded the datasheet using their datasheet link there, and that gave me a drawing of the connector, which is this thing that you see here. And so it gives you in the upper left an overhead view. It gives you a side view. It tells you what the card sliding into it when you make a PC board for that end. And that'll be another component that I'll create at some other time, which would be the mate for it. And I'll follow all of those dimensions and PC board thickness requirements. So let's see if I can get to this drawing here. And then this slot comes in different widths, like number of pins. So it comes in something like 80 pins or something, and down to like 20 pins or 40 pins. Here we go, pin count. Hopefully it's zooming in for you. So they tell you that you can get 60 pin, 80 pin, all the way up to 200 pins, and that affects certain dimensions, which they list out here as A, B, B, C, C, D, D, E, E. and other dimensions are fixed because the connector is only so wide and other stuff. So this is the drawing that I'm starting with, and I'm going to use certain parts of this drawing to enter it into the CAD software. So the first thing I start with is the actual physical part outline. Like, what is it? How much space does it take up on the board? So I'm going to go into Eagle. Somewhere I have an Eagle. So I think I have to switch over to screen mode. There, nope, that's not Eagle view. Okay, so my desktop. So let's slide over to Eagle. So in Eagle, I've opened up the library. I've created a noodle library. So all the parts I'm making for SpedQ, I put in a noodle library, and I can always export those out to other libraries later. But for now, it makes it easy for me to have these parts in one place that she is using. So, do you see me doing this on your screen? Like, am I running the software for streaming correctly? It's like, it's just a black screen, Mark. Do you see that Eagle window?
You're
am I running the software for streaming correctly? It's like, wow. Just a black screen, Mark.
There.
And a 15-second delay. All right, you can turn the volume off. Okay. Okay, so first thing you do in Eagle is we are creating a symbol. So over here on the fourth column, we are going to say down here at the bottom, if you can see me clicking this, add symbol. And we're going to name this, I usually name it vendor name dash, and then maybe sometimes a part number. So in this case, I'm naming it amp, and then I'm going to slide over to my drawing. And I don't know if they have a fancy name for this series. It just says Cool Edge Connector. So I think that's a good name. And then Noodle only needs a few pins. So let's see. What is the... on this one, I'm looking in the drawing, and I want to know... Okay, they go from 20, 26, 40, 50... for signal count on this connector up here. So let's see here. Is that per side or total pins? I think that's total pins according to this. Looks like a 40 there. But we will know shortly. So, yeah, that's, wow. Yeah, that 20 pin one is only like a centimeter, a little over a centimeter long, the slot, which is kind of, that's a tiny little, no. No, we can always go extra, because the one thing with card edge connectors is the pin can only take so much current passing through it. So depending on how much power you use, if you're powering motors or whatever, then you double up on ground pins and equal a number of voltage pins. And then that way, if let's say a pin, which I don't know if I want to take the time, let's see if I just see it here. Sometimes they tell you how much current a pin will take. Do they tell me? Current capacity per pin. That might be in a spec somewhere else. But I'm not seeing, I'm not seeing quickly offhand. But here's a good example. Like, if you want to use a bunch of pins for power, hopefully you can see my PDF zoomed in here. On one edge side of it, they're just making one big, you see these two giant squares? That's the area where multiple contacts will make contact and provide more power for pin, but you're burning up 4, 5, 6 pins. So that's a technique they say to use that. They're not telling me. I'm just not seeing offhand like what the current per pin is, and I probably could look back at the spec. In our case, I don't think we're using all that much power for this, except for his noodles. Except for the motors. So what I'm going to do is probably at least give a pin per motor power wise. So But since this is a small connector and has high density, signals don't really use power; they just passing signal. So for the my choice of connector size for her, and I can always add connectors later, but so they're giving me let's see here. They're giving me 20, 26, 40, 50, 60, 80, 100. So I think if I look at the width of the connector, which is dimension A, if you see up in the upper left, dimension A is the overall width of the connector. And I think a decent sized connector is what for that to hold the card. It's physically holding the card in too. So do you want like a 3/4 inch connector? Yeah.
I mean,
Like a 20 millimeters ish.
what are you asking me?
Like how big the connector is. A 20 millimeter connector gonna be like cartridge connector?
Big.
You want it big?
Yeah.
Why?
Because that's how Nintendos are. It's a big connector.
Okay, well that's like 200 pins. It's more to solder and more to do. So.
Can you not just not?
Well, you're gonna make supports on either end of his brain board to hold it in, anyways, because that's not the right.
No.
It's not it's not how you're mounting this board. That would be dangerous and bad. So it's just a connector, but you don't need like no pins. But so I don't think we're going to use a lot of these pins because you're talking to the Jetson Nano, probably a serial port or something, and maybe a couple of I/O pins. But I don't think you're doing a whole lot.
Okay.
The Jetson Nano's I/O pin connector looks like it has 20, 30 I/O signals. So that's at least a starting point. So why don't we shoot for the let's go for a 50 pin. What is F? A. What is dimension A? A 40 pin connector is 1 inch long. 40 pins plus pin. Okay, we'll do 50. 50 more pins than you'll ever need for Noodle Sport. It's more than the Arduino has in pins. So
most pins.
So let's do 50 since that's a good number. It's probably more pins than anybody would ever use. You have extra pins for some power and ground. And you can always spin the board, but this is a good starting point. And once we have a connector, if I need to make another library connector and add 10 pins, that's kind of a simple matter of just kind of cut and paste and slide and move since you already have a lot of your stuff worked out. So let's get to this. I'm going to do the 50, which is, hopefully you see this zoomed in, is these dimensions here, 50, A, B, C, D. I'm going to be reading off of those when I do the connector. So that's I'm just going to go with that one. Why not? Looks like a fun time. So the first thing I'm going to start with is this here. I'm going to do the overhead view in my CAD. So edge 50. I think that's a good name for this symbol. Is that right? Oh, I'm doing sorry, I'm getting ahead of myself. The symbol is just a connector, and so we're going to be generic about it, and we're going to call this we'll call this con edge, and we can call it, we'll just call it a 50. That's fine. Con edge 50. So I'm creating the symbol. So this is the symbol that you see in the schematic part, not the PCB, but the schematic. I always like to, in Eagle, do my description. So this is a connector edge. And then we'll say 50 pin. All right. So my stream looks okay, honey? Does it switch? Okay.
I think you look good. You're made out of pizza.
Made out of pizza. Okay. I got that. So over here on the left, in Eagle, I usually start with a pin. And pins in Eagle have this, if you look up here, you can do a point, you can do short, middle, and long. And so that's just the length of the pin. So here, well, I'll just put them up here just to show you. So this is a point, and you can see it just made a circle and nothing else. A short does this, a medium does this, and then the long pin is longer. And you can see it's 0.1 inch different every time. And the reason you'd use these is if you have like 10, or is it 9 and under, 9 to 0 pins, or 9 to 1 pins, the pin number is going to print next to the pin in the final version. So it's actually going to put the number above the little red line. And the problem is when you get to chips that have 100 pins, those 3 digits now draw on that red line, and that's when you want to use a long the longer red line. And then on chips where you have like transistors and stuff where you have 3 pins, you use the short line. And then sometimes when you're trying to customize a body and you just want to draw your own red line, you use the point, and then you can kind of embellish from there in the Eagle. So I generally, let's see, this is 50 pins. I'm going to use the medium size one, since when you do pin 49, it'll draw above the red line and it'll take up almost 2 spaces, but it won't interfere with your wires that are next to it or components or whatever. So it's more about a spacing and aesthetics than anything else. You can use any one you want and your schematic will still work. So it really comes down to how do it look. So let's back this out. So I'm going to do the middle pin there, and then this is this plus in the middle is the center of the connector, and I usually center that that is going to be the center of my connector. So I'm going to start pin 1. Let's look at the spec real quick and see where pin 1 is on the actual connector. They have placed pin 1 okay, so in the drawing you see these diagonal lines with these arrows here. It's S1, which is pin 1, and then they're staggered. They're on the opposite side of the connector. You can see they're off by half the pitch on the other side. So the pins aren't facing each other. They're actually like zigzagged. But pin 2 is the opposite connector, and then pin 3 comes back to the same side. So you have an odd row and an even numbered row all the way to the end of the connector. On the right hand side you have SN minus 1. So that would be, if it was a 50 pin connector, it would be 50 minus 1, which is pin 49, and then 50 is the final connector on the upper right. So we're going to follow that in our drawing so that we can put the dimensions in correctly. So but I'm going to match my symbol so that it maps and it's not like mirrored or upside down or reverse or just confusing. So except for the stagger, because that would make my connector really big in the schematic. So but I'm going to put the pin 1 in the upper left in my Eagle library. So I'm going to start with pin 1 about here, and I'm going to move these later, so I'm just going to kind of rough these in. So I have this one, and here's another trick is if you're doing Eagle creates this $$1 for your pin name. And the reason they do that is if you're doing like logic chips and other things where you're able to swap pins on things, they create these parameterized pin names. But since I'm doing a hard connector and I'm not ever going to swap pins out or anything like that, I'm going to rename the first one. I'm going to drop one and then rename it. And I'm going to just name it 1 for my sanity's sake. And then we're going to now copy. So I'm clicking the copy icon over here. Now I'm going to just copy the pin. And then when you copy a pin, and I'll put number 2 on the right hand side, notice that it's numbering them for me. So that's one less thing that I need to type. So put 1 pin down, name it the pattern you want, and then it will just increment the number of that after that. So now that I'm in copy mode, I'm going to copy alternately these And sometimes you can get away with copying a group of these, but sometimes Eagle will not recognize your pattern and it'll scramble all the pins. So I'm just going to, for 50 pins, it's not a big deal. But I sequentially put them where I want them. All the way up through 50. So and Eagle keeps improving. I'm sure there's like some shortcut tool that I'm missing that makes this even faster. But this is how I've done it for like 15 years on Eagle. So almost there. All right, 50 pins. Okay, so the other thing I'm going to note here is the little plus thing, this little target in the middle of your part. That's we want that to be the center. So now is the time we're going to move some stuff around. The pin numbers are a little crowded, so I'm going to move all of this over by one, I think. Am I going to get away with that? Probably not. Let's just move the whole thing. Let's just center the whole thing right now. So I just selected, I used the select tool and I selected everything. And then I'm going to use the move tool over here. I'm going to right click and say move the group. And so they all move as a group. And I'm going to take this plus thing that's in the center and I'm going to make that the center of my part or thereabouts. And I think that's good. So that's symmetrical and centered. And now I'm going to draw a body around this. So I'm going to use the line tool. And so instead of the default width, I like fat lines on my components that give the body some body, as it were. And I usually use 024. And then I'm going to draw a box here around the part. Yeah. And then so now I have a connector with a body around it. And then I want the value. I'm going to add name and value to these. So these are two things that get filled when you create the device. They get filled in with the name. So for the name of the part, you actually use the greater than symbol name like that. And then you're going to place this thing called name. And then you can set the alignment. And Eagle in the last few years added better alignment tools, like they do full on center. And I usually use for this, I just set this to center and I move it to the middle of the part on the top. And then the size for these, I usually put the name at like about 0.1. So it's a little bit fatter. And then I change the ratio to 15%, which is bold text in a font wise. So it's a little fatter. And then I'm going to fine position this by holding the option key down, and I can fine move this thing down and put it so that it's kind of just there's a little bit of a gap above the connector for that. And then for the next part, and then and I'll show you another trick here. So I'm going to hit escape, and then that brings the window back up, and now I'm going to do value. And that's an auto-populated value, or a number that gets populated when you create the device. So if you reuse this connector, it'll update with that. So this is a smaller size, and I usually go with something like 0.05. So see, that's smaller, and then I put the ratio back to 8, which is skinny text. And I usually try to put that inside the part. So my two options are to make this part wider and put the value like sideways down here, or put it up here. So I already know this connector has a long part number. It's like 10 or 20 digits. So for it to be readable in the schematic, I'm going to probably put it sideways right here, like about here. And then to make it readable, I'm just going to move the pins out. It'll be a slightly bigger connector, but it'll just at least be aesthetically like you can read it or understand what the part is. Or maybe, now I'm looking at this, you know what? I think we have enough room in the schematic. I'm going to just put the value at the bottom here. And then the pins, because there's nothing outside here, but that'll keep my connector skinny. So I'm going to position this about here. And that'll populate in with that long amp part number name or whatever we call it. So so there. So the other thing you have to do is you should in every part put a name and a value, but make sure that they're finally go through and make sure it's on the right layer. And I have screwed these up before, and they look. You find this out when you're doing your board layout or your schematic that they didn't make it to the right place. But if you go into properties after you place this, and then instead of the symbol layer for your name, you're going to put it to the names layer. So there's a layer just for names, and it makes it a different color, and it has an effect in the output files. Sometimes it can make a difference in how things look, especially in the PCB level. So that's now gray, and it's in the name layer, and then the same thing, value. Put this in the value layer, and so those are in the proper layer. And that's pretty much the connector. That's most what you need. So the other thing, if you're doing like logic gates or actual chips, you can actually change the each of these pins. It says IO0. You can, in properties, change the direction. So in a connector, it is an IO pin. Unless you can, like, if I dedicated this connector to a particular purpose, I might put power pin. Like there's power passive, and some of these I don't remember. You have to look them up on Google. But for the most part, the easy ones are like if you're doing like an Arduino chip or something, you'd have definite inputs, you'd have definite outputs, you'd have some that can be programmed input or output. OC, I think, is a clock pin, output clock. I don't know. So some of these other ones I forget, and then there's power, passive, supply, and so you use them carefully because they get used by Eagle in its electrical analysis, and will tell you if you have, let's say you have a network with all outputs or one output and no inputs or whatever, it'll tell you that in your electrical check section, and that can help you proof out whether your design is correct or not for a lot of designs. So if you use these correctly, you can leverage them later in your design to find problems that you might have created. So definitely on Google, research these. There is a couple articles about exactly what each of these is and how to use them. And just off the top of my head, I forget most of these. But I usually use in, out, IO, and power for like my powers and grounds for like chip designs and stuff. So, but it's a connector. I'm gonna leave them all as IO, and then the number next to it, I believe, is the swap layer. So if you're doing like AND gates, like on a logic chip, you can swap pins on AND gates because it doesn't matter which AND gate has the signal, but you can move that around in your design and optimize layouts. So they have this thing called swap level, and you can do pin level swaps and gate level swaps and all kinds of things. But you can change the swap level on here if this were an actual component. Like this is a connector, so you shouldn't be swapping. So we make them all 0, leave them alone. And then you can change the visibility of the pin, and that means the pad and the pin is the when you make the connector, there will be a pin number drawn outside where the word IO0 is. You'll see a number there, and then you can name the pins, which is the actual. I've named the pins the number, so these will kind of duplicate in the final connector, but you can leave them blank on the middle and then make the pins on the outside. So, but you do that by choosing one of the visible modes, whether they're off, pad, pin, or both. So that's up to you, and I may change that later based on how it looks in the design. So So that's it. That I've made the symbol. It's all done. I've added a description, which will appear in the library window. And you can always go back and change this, but for the most part, that's a basic connector. We've done it. I'm going to hit save. So now let's do a footprint of this connector, and this is going to be the cool edge. I usually do vendor and then what it is. So I say amp cool edge 50, and I think for right now that's kind of specific enough for the connector we're doing. And it says yes, create a new connector. All right, so now we're looking at the drawing, and the first thing I do is the document layer, which helps me have a reference for what the actual connector is taking up space on the board. So I'm going to go back to this and start entering this part. So I have dimension A, first of all, and then I have the width of the connector, which is down here in the lower right on the screen is 7 millimeters, and that doesn't change for any of the connectors. So I have A for one dimension and 7 for the other dimension, and I'm going to put that in my document layer. So let's see what A was. A on a 50-pin connector is 29.30. So let's make a rectangle with that dimension. So I'm using my line tool, and I'm going to change my layer over to T-Docu. And the other thing, T-Docu comes in as gray. I always change this because the white layer, or white and gray, are the Silkscreen layer, and I get them confused. So for them to highlight and tell me that they're not going to end up in the board, they're just reference information. I go into I click the gray square in T-Docu. It brings up the customization, and I'm going to customize this. I'm going to tell it that the color, instead of gray, is going to be, I just pick one of these yellow, two-tone yellow. So like this color, this brighter, this whatever lemon mustard color, and hit OK. And then while I'm at it, I almost never use B-Docu, but I'll click it anyways. And then I use the darker of the same hue. So now when I draw my outline, which is, was that 29.3 by 7? So I'm going to rough in a rectangle, and now I'm going to actually just type in. So this is a 7 millimeter wide, so it's going to be 3.5. Oh, and I already missed to tell you something before you start drawing. The most new components are all metric. Very few components come in as English units anymore. So change your scale to millimeters, and it will make your life a little bit easier for a lot of components. But try to do that first. I always forget. So now when I draw, now I'm drawing on a metric scale. It'll make just correcting things easier later. So I've roughed a rectangle. I'm going to do the width, which is going to be up 3.5 millimeters, which is half of 7, and down 3.5 millimeters. So that one's at 3.5. I'm going to edit this bottom line. Minus 3.5. Minus 3.5. And then this was, again, 29.3. So half of 29.3 in either direction is, oh my god, brain fart. Let's do a calculator. 29.3 divided by 2, 1465. Okay, so we're gonna do 1465 in each direction. And this side. And the main reason I do I didn't used to do document layer, and I don't see a lot of components that use it, but the reason I do this is now I have this kind of shadow image of the actual connector. I do use it for some documentation when I'm doing placement and stuff, but it helps me when I'm putting the pads down and the other stuff down, that if I'm off by some number, that if I nailed the documentation numbers, these basic how much space does it take up. But if I'm off by something, I'm going to notice it sooner than if I just went happily along and put pads down and had the board made and it comes back and the part doesn't fit. So this is kind of a sanity check as well. So while we're at it, let's change the description in here. So this is a Amphenol Cool Edge 50 pin connector there. So so that's the basic shape of that edge connector. So now if we go back to our PDF, the next dimension I care about is probably the next profile. I'm going to add the dimension B in there, which is the lines, so that I just have an idea of where the taller part and the shorter part of the connector are. So let's do B now. So dimension B is 25.30. So let's add a line in here. I'm going to rough in a line. And then I'm going to, in properties, I'm going to change this line. So this was 3.5 minus 3.5. And 29.3, half of 29.3 is what's Bedku? What is half of 29.3? Did I read I probably read the wrong number, didn't I? I can't even use calculator. 29.3 divided by 2. No, that was I read the wrong number. 25.3. I suck.
Stop.
25.3 divided by 2. Oh god, math. 1265. And this is why I don't play blackjack in Vegas, because I can't add two numbers together. 1265. 0.65. 65. All right.
And he's an engineer.
I'm an engineer, and I need a calculator, and I've needed one since grade school. Take that, teachers. So I'm going to copy this line and move over here, and then I'm going to edit it to make sure I put the right dimension in. There, that kind of represents the actual taller part of the connector. And now let's do the slots outline, which is in the drawing here. The slots outline. Oh god, where am I? Is dimension C is the inner actual card that slides in. So let's throw that in as a reference. So we're looking at C, and the slot width, if you look over on the left of this, is 1.8. So we're going to make a box that's 1.8 high and C, dimension C wide. Dimension C is 21.8. So 1.8 and 21.8. So let's rough in another rectangle. And then we're going to change this one to 1.8, which is minus 0.9, and then 0.9. And over here, same deal, minus 0.9, 0.9. Okay, and then the other dimension, which I already forgot, is 2180. So half of 2180 is 10.9. Did I nail that one? 9. There's that, and then there, 10.9. Okay, and that's my slot. And you can add all of that information in there. I'm being generic today, but sometimes if I'm OCD that day, I will literally draw every line in this. Like, I will ghost that thing, like down to every little detail, and I'll make sure they're right. Or even add those little card edge pins in. But I don't I'm not feeling it today because I'm streaming. So I'll leave leave that alone. And then the other thing you probably should do, so now things that affect footprint are the pins in this thing. And this is another thing I add in, is I make a T-DocuLayer version of the pins as their actual size, so that when I add the surface mount pads, that I have the right amount, a little bit of extra pad around them. So, but I have an idea of how big the actual pins are. So I'm going to draw those next. And those are the tabs that are on the left and right. That's the solder down tabs that keep the connector from ripping off your board. And then I'll do individual pins. So I'm going to do that next. And so that says 2 locations on here, 2x 3.00. So that means there's a 3.0 wide tab in 2 locations, the left hand and the right hand side. So let's rough in that, and then I'll get the other dimension next, which is, I see it there. So let's get a 3mm wide tab roughed out in there, and I'll show you how I do this a little bit different. So for pads, I use a solid shape instead of this lines. I use the polygon shape, and then the trick here is you set the width to 0, and this will, by setting the width to 0, this shape that I'm drawing right here now, it fills it in solid. If you set the width to some width, it'll just draw a line like it did before. So where is it? And it's solid. It's in solid mode. But I set to 0 because I don't want to add the thickness of the line around it. So now I'm going to edit this tab that I just did, and I already know that it's 1.5 up and 1.5 down because it's 3 wide. And then there. That's a polygon edge. Okay, so I'm going to do the opposing edge. 1.5. There, and then the in the drawing, the tab extended out 1mm up here on the right, on the right hand side of it, next to the A dimension. It extends an extra millimeter past the A dimension, and then its inner pad. Let's see if I can find that in the drawing somewhere. Where's the actual pads? Where do they dimension the pad itself? Oh, here they go. It looks like in this drawing here that the pad is 2.35 millimeters off the post. We'll add the posts in here in a second. And these posts keep the connector aligned to the board. So they're telling me how to dimension this thing. Yeah, they're just, let's see here. So I should add the posts in because they're references, and the posts are symmetrical on dimension F in this drawing. So if you can see here, so let's add the post things in the document. So dimension F, if I go over to the table, dimension F on a 50 pin is 2320. So I'm going to add 2 circles at 2320. Oh God, where'd my thing go? There. So let's use the circle tool, and then we're going to somewhere half of 2320 is about 11 or 12. Let's just go to 12. So let's just add the circle in here, and then edit this. So now this circle, I'm gonna go back to a width. I'm gonna just set it to a really thin width though, like 0.01, like that, and then I'm going to set it at 2320 divided by 2. So let's do this thing. 0.2 over 2, 11.6. So that's at 11.6, and then its radius. The radius is the post on the left has a different radius than the post on the right. Where are they giving me this thing? Is it really 112? I think it is. Okay, so the post is 1.12. It's down here in the bottom underside view of the connector. 1.12 diameter, and the other one is a 0.72. So 1.12, and then the CAD wants a radius. So again, let's do some math. 1.12 over 2 is 0.56. So there's that radius. And then I'm going to copy this and put it at the other end here. And then it's the opposite, 11.6. This should be positive 11.6. And then its radius is going to be 0.72 over 2, which is 0.36. All right, so that's the reference for the 2 pins. And then we're going to use that as a reference for that tab, because the drawing references the inner edge of this tab. You can see here the footprint for this tab, which is bent down. So the actual the metal comes out of the side of the connector, and then it bends down and hits the PC board. But the actual pad is this area here, or approximately. So I'm going to kind of do that. So I'm going to bring in on the little metal tab that I drew, I'm going to bring it in by make sure it's 0.35 away from that post, or 2.35 away from that post. So let's see. So it's going to be this number, which is 11.6 plus 2.35 is 1395. So this edge is, the edge of this polygon is 1395. So that's the inner edge of that. And then this one already extended out a millimeter past the body, I believe. So 1465, and this would be 1565. There, and then we're going to do the same for this side, and this is actually symmetrical, so let's do this. 1565, let's copy this connector, or copy this pad, and then I'm going to set this to 1565, and then I'm going to match this number, 1395. Okay, so that's my these solid areas are where I'm actually going to have SMD pads and solder them down. So let's do the 2 rows of pins here in my document. So now they give us some dimensions on how fat these pins are. One of these. Let's see here. Okay. Yeah, okay. They give me an underview. Are they telling me how fat the pins are? I'm not seeing in the drawing. I'm looking in the drawing for how actual wide these pins are. So over here they give me a recommended footprint, and you can totally just do that. But I've been screwed over so many times by the recommended footprint, because the main reason is this footprint is great for factory surface mount pick and place machines. But if you're hand soldering this connector, these pads are not long enough for you to get a soldering iron underneath it, or to get heat in there and feed solder in. So I always elongate these, but sometimes these pads are way oversized or there's some other thing. So I never trust them. I go by my own experience. Um, they're a great guide to just sanity check, but I almost never use the recommended manufacturer recommended footprint. They're almost always like done by a junior engineer, and I'm not gonna do that. So um, so what I'm looking for is the actual width of the pad, and they're showing me the bottom of the connector, and they're showing me here the length of the pins, or this pin at least. They're not showing me wow. Yeah, they're showing me the length of the pin, but they're not showing me the width of the pin. And I have to assume that the width of the pin is also the same width of the pin in the socket, but I'm not seeing that. So I may have to just take a guess at that because we'll be close enough. But I don't see a single dimension that tells me the actual width, physical width of the pin. They're giving me the pitch, which is the 0.8 that we see there. But they're not putting a dimension on the physical width of the pin. And I think I think what we can do is the card edge, which is the thing that plugs into it, is probably going to be good enough if we use that width. So what are they telling us the width of that? So I'm going to wing it, and I'm going to use what they tell me, and that's a 0.5 millimeter width pad for the card edge. And I think based on this drawing, what I'm seeing in this drawing, and some gap and all that stuff, that if I make the pad 0.5 inch wide, I think my connector will be fine. So I'm going to add that to my dimension. But yeah, they didn't give me, I'm not seeing it in any other drawing. I'm not seeing a width of the actual pins. So I'm just going to wing it here. So let's do that. So 0.5 millimeters wide pad, and then we'll dimension this. So again, I did a polygon last time, but you can do if it's just a square. This might make life easier. I'm going to do this rectangle, and so this is going to be that. And then this is going to be, I need to find the dimension where they start it. So let's see. All right, so pin 1. All right, let's just nail pin 1. Pin 1 is where am I referencing this from? I think they go from the center. So it looks like it's probably relative to this because the pins are in the same spot, but not always. I don't want to just trust that card edge because sometimes they move, pins shift inside of connectors or the way they've assembled it. So I'm looking for a reference that tells me where these pins are. I'm not seeing any reference where to place these pins. So I guess I'm at the mercy of, I think I'm at the mercy of the card edge for the pins. Or actually their recommended footprint again, at least for the centers. I can kind of do this. So where are they referencing? Okay, so the first pin, this is kind of the info I want. So from the peg that goes on the board, my first pin is 2.2 millimeters off of the peg. So I'm going to put pin 1, 2.2 millimeters. I'm going to center it on that, and it's going to be 0.2. It's going to be 0.5 wide. So 2.2 millimeters. So here's my peg. So this dimension is 11.6, and then we're going to subtract or add 2.2 to it. So again with the math, so 11.6, 11.6 minus 2.2, 9.4. So the center of this pin is going to be 9.4. So this is so we're doing this rectangle. So we're doing 9.4 minus 9.4 minus another 0.25 is minus 9.65, and then we're doing 9.4 plus 0.2 minus 0.25, which is 915. Yes, there. So that represents the pin, and actually we're doing pin 1, which is down at the bottom. So we're going to make this for now -1 and -3. So I moved it there, and then we want to get the dimension for the actual y coordinates. So that is left and right wise, that is correct now. So let's go get the other coordinates off of this. So in this case, we are looking at, yeah, we'll just use a reference. So it's 1.2 millimeters long, and it's centered on this. On the left, you see 2.6 millimeters from the center, which is 1.3 from the center is the lower edge of the pad plus 1.2. So 1.3 plus another 1.2. So here, this dimension is going to be minus 1.3, and then minus an additional 1.2. So this, in the document layer, this little square represents where the actual piece of metal that is the pin touches the PC board, and so that becomes the reference for where to put our surface mount pad, and how much extra space we have around it and that kind of thing. So that nails that down. Now we're going to just duplicate this across the row based on the pitch. So the next trick is, the pitch is 0.8 millimeters. So what I do here is, now that I have pad 1 for pin 1, I'm going to go up here and change my grid to the pitch of the connector, which is 0.8 millimeters from the drawing, and my grid changes, and now when I copy this pad, it'll be exactly at the pitch that the connector wants, which is 0.8 millimeters. So I'm just going to go across n number of times. I can probably do this to the middle. So I'm going to do that, and I'm going to shortcut this. I'm going to highlight that. I'm going to copy the group, and then just because we're still on the same grid there. So that should be 25 pins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 22, 23, 24, and I think I need a 25th more. Did I get this side to side? Oops. Not what I wanted. Okay. That's 25 pins, and does the drawing does this reflect our drawing? Does it look like it, right? And if we look at this, there's a little more gap on the left on this bottom row than on the right because it's a shifted pin. And then this second row seems to start right on the middle, I think. So let's double check this. Yeah. So that's looking right. And then this is this whole row is the same but opposite. So I'm going to select this whole row. I'm going to copy this group, flip it, and then this, remember this is offset, so that is it there. So that looks, the middle of this is the middle in between these two, so this looks what we want. So this is now a ghost image of the actual connector that will go on the board. So all the work I do now will be referenced to this. And the other thing I noticed is this right hand peg is offset. So let's go look in the drawing and offset it from the center. So let's see here. So that's the bottom. Let's use our footprint again as a reference because so you might be tempted to use this reference here, but this is the bottom view, so it's a mirrored. You're looking at the bottom of the connector, but our PC board's looking at the top of the connector, so that's a nice reference to have. But I'm going to use the one from the footprint, or at least I know now. So it's 1.12. No, it's 1 millimeter off of center. So we're going to bump it up. Oops. So let's go up here to the footprint and verify that it really is. Yeah, so it's 1 millimeter. Here's the set. This dotted line is the center, and then our hole is shifted up by 1 millimeter. So let's go do that. So 1 millimeter. So this, we're going to add 1 to this. There. So that is that. So now we can actually do the guts of this connector. So when I start doing the pads now, so I'm clicking the SMD pad. So I'm creating a pad, and I'm going to put it here, one here for this one. Let's set my grid back to 1 millimeter. There. So I'm going to rough this in. I'm going to put it right about here. And this is going to, I'm going to edit its properties. I'm going to rename it to pad 1. And then, or actually I call it mount, MNT1. So this is a mounting pad and not an actual signal pad. And then we'll have to find its center here in a second, but let's make the pad size about what we want. So remember, this was a 3 millimeter pad, or a 3 millimeter pin, and the pad needs to be slightly bigger for the solder to kind of anchor down on there. So let's make this like a 3.4 high pad, and then the width, I forget the width, was it around 2? Let's just do 2 for now. We're going to change it. So there, and then the other thing a lot of people don't use in their pads is roundness, and this helps when you're soldering and you have sharp 90-degree corners. You can get all kinds of weird stuff happening with soldering, or just soldering is slightly less easy. So if you want your solder to flow better and just have better surface tension when it's melted and stuff, I put a little bit of roundness in things, sometimes a lot, sometimes a little. So roundness is, let's try 50%. So that's a good roundness. It does help boards etch better because sharp turns in PCB etching can cause manufacturing issues, and usually in modern days that's not really a big issue, but in the past lots of right turns on etching caused, because it took more time to etch a board, ended up under etching other parts of your board. So just from a manufacturing standpoint, this has always been the rule of thumb that we do. We rounded pads off. But I say in modern equipment now, they've fixed a lot of those problems. So you could probably do anything you want in a PC board these days and won't have a lot of manufacturing issues. But this is what I do. It definitely just looks better too. So round your pads by down to a 50% amount, and your stuff will just look nicer. But it'll actually be a little easier to solder when you're soldering by hand. So the other thing is I'm going to center this pad on this thing now, and I can use this rectangle as a reference. I think it's this one, this upper line. So this goes from 1395 to 1565. I want to split the difference of that. I can go back to the drawing, I guess. Or we can eyeball it. Let's eyeball it. Why not? Since we're using this as a reference. So I'm going to set my grid to 0.1 millimeter. And I'm going to take this pad and just move this until it looks about right. Not too far. Close enough. All right. So I'm going to note this dimension though. So this is 14.8. I'm going to copy this pad. I'm going to put it at 14.8 on the other side of the connector, which I probably will place by hand. So let's verify it. 14.8. It's called mount 2. So everything looks happy. All right, those are my mounting pads, and now I'm going to do a surface mount pad for this. So let's get a pad in there. All right, so I'm going to resize this pad, and so the thing you're going to have is if you just followed the manufacturer footprint for this, you probably wouldn't be able to get your soldering iron underneath the connector, because remember the pins are underneath this connector, like way under. And the thing you have to do is if you're going to hand solder this connector is you're going to heat the pin up and feed solder in, and then that's going to heat the pin and then flow up the pin, and that's going to take a few seconds. So to make this easier is we're going to extend this solder pad out about 0.5 millimeter, which is enough for you to get a small tipped soldering iron on and get heat up into this connector and get solder in there. That's the difference from the recommended footprint versus what I'm doing. If you're going to reflow this, perfectly acceptable. If you put solder paste down on all these pads and you use a heat gun, you could totally do that too. But I will, since I'm only making one board for noodle, I'm gonna be hand soldering this. I'm not gonna go set up a reflow setup just for noodle.
What?
So okay, so I can eyeball this one. So the width actually looks great. I usually round my metric up to 1.3. Actually, sorry, 0.7 on this. So I usually make the pad a little bit wider than the physical pin, just a hair, just so solder can kind of hit some, flow around it a little bit. And then I'm going to make the pad length. I need this to hit the back edge of the pin and come all the way out from the connector. So I'm gonna bump this to 3 and just see how it looks. And then I'm gonna change the offset here, maybe 2.6. How are we looking here? That's actually looking pretty nice. I think I'm gonna stick with that. So there's this long pad, and so I'll be able to actually put solder or the soldering iron right here at the edge of the connector and feed solder in, and the solder with good flux in my solder will just flow up into this, and then this pin will heat up, and then this will all melt together, and that's how I will solder this, because otherwise I can't get any heat up underneath there. So that's why I'm extending this out, and then I'm through experience I've realized that I need about 0.5 millimeter, whether it's a chip or a connector or anything, of pad for the soldering iron to touch that and deliver the heat up to the pin. So in this case, you can see 1, 2, 3, 4, 5, 6.6 millimeters from the bottom of the connector. So that's a good amount. And then again, I'm going to set the roundness on this to 50%. So that's a goodly amount. So there, and now let's set our grid back to 0.8. And then I'm going to copy this. Actually, oops. Let's name this pin. Change the name to pin 1. And so, because these are opposite sides, this is the only tedious part, is I have to reverse copy. Actually, I'm going to set my grid to 0.4 because the opposite side is off by half of the pitch. So there, so I'm going to copy this. I'm going to rotate it and then put it there, and that will be named 2. And then this one, this will be 3, 4, 5, 6, 7, 8, 9, 10, 11. Is there any chat?
I don't know.
Are you not following my stream?
But I'm working on.
You're supposed to be helping me.
I'm doing the other half of the do.
Would you mind just looking at the chat and see if there's any questions?
You have 2
viewers.
Bradley is here. He says.
Is it?
He says more pins than you'll ever use.
Is it weirdo, dude?
Yeah.
Hi, Bradley.
Even when it's true. I don't know if he's still there. And then Nikuman was in there and said pins.
Pins.
So many pins. And that's, I think there's, I'm going to like it. And
none of your friends are in.
Nikuman is still there. Mark, what are you?
All right, Nikuman, we're almost done. What?
Smurfs.
Wait, what?
He wants to, says, what are you planning to do with the Smurfs?
Smurfs of what?
Because you're Gargamel.
I'm what? Did he actually ask that?
Yes.
I'm going to eat them in a pie.
Why?
With my cat.
Why would you do that?
Because they're delicious, I think.
Why? Why would you eat your cat?
No, the cat and me are going to have Smurf pie. Until we find out Smurfs actually don't taste that good, and we're going to be like, oh, all this time.
Cool. When I talk, I am Robohemian. I'm the whole Robohemian. Doesn't even say Sarah. It's just
That's
like,
funny.
nope, you don't get an identity. You are your YouTube channel, Sarah.
All right.
Keep talking.
My stream is on my CAD screen, right?
You are clicking a bunch of nodes.
All right, so at this point, I have most of my connector done. So I've done these 50 pins. I've done my mounting pads. I do need holes in the board. So these are reference circles that I drew, but I need actual drill holes in the board so that the connector's pegs will slide into that and keep the connector exactly where it needs to be. So I'm going to do that next. So in this thing, there is a drill. There was a hole. Okay, so there's an icon called hole. We're going to click it, and then we're going to move this about here, and then we're going to fix it. So so in the circle wants 11.6 as the thing, and a diameter of 0.56 or a radius of 0.56. So we're going to match this to this. So it's already in the right spot, and the diameter of the drill needs to be the same as the hole. So I believe that said 0.56. Is that right? Okay, so drills come in diameters. Circles on the CAD are drawn in radius. So double this. So 1.12 is our actual pin. So this will be 1.12. to drill. So that's probably going to be fine. I noticed there's that board manufacturers, if they don't have a 1.12 millimeter drill, they go to the next size up. So there probably will still be a little bit of slop in this, but sometimes you need to build in some margin so that your parts aren't too tight. I have almost never had that problem where a part was too tight unless I actually made an actual mistake in the number. But I found that most manufacturers tend to round up their drill bits, and a lot of my connectors actually tend to be the holes too big. They're bigger than I expected they'd be. So I'm going to go with the exact measurement that the peg is and hope that it's right. I'm only making one board, so I'll ream it out with a drill if I'm wrong.
But says like hell you will.
So there. So that is the hole size there. And then we're going to add a hole on this side. Same thing.
I'm going to add a hole.
I'm going to get the actual XY coordinates here. It's 11.6 and 1. I'm going to modify the properties of the drill I just dropped and then change this to 1, 11.6 and 1. And then this diameter is, actually I already entered it, so the diameter is this times 2. So 0.36 times 2, 6, 0.72. So let's do 0.72. We could probably do 0.74 just for grins. There. So that will drill holes in the board for that part. You have pads, and the only thing you're missing now is the silkscreen and the name and value tags. So let's add those in now. So I'm going to set my grid back to 0.1 millimeter because I'm doing the fine work now. And I'm going to do the silkscreen for this part. And so you go to line, and then your line's width on this is, I usually match it to if the board is a 6 mil, they call 6 mil board process, which is standard for the hobby boards now, is actually 0.1524 millimeters. So maybe let's go to 0.2 millimeter line width. That's a nice thin line. You can go fat if you want. Totally up to you. And so the silkscreen doesn't have to be 100% accurate. It's just a visual marking for you when you're putting the connector in the board. Where does it go and which way do they go? So you want to avoid your pads. The other layer to turn on at this point is the stop layer. So the stop is that solder mask that's on your board, and you can't put silkscreen where there isn't solder mask. So you don't put silkscreen here. Here, let me go to T place. So I'm drawing in the T place layer, but if I do this, let's say I do this. So this is I put this white silkscreen here. The board house will chop off this part that's in this shaded area where the pad is. They'll mask it automatically for you, but I don't like to trust that they will. So I don't. So I draw the silkscreen where I want it and not where I don't want it. So I'm going to put, so I'm going to have this line start right on the edge of my silkscreen. And then I'm going to go over here and I'm going to keep it off the edge there. So I'm going to do this corner. I'm going to do this corner right here. I'm going to do this corner. Outside. All right. And then we're going to do this corner there. Goodly enough. If you want to be fancy, you can add silkscreen for the slot so that it looks like an image of your connector when you put it in, but I usually don't do that. So that tells me where the slot is to plug it in. These mounting holes, these key holes, because they're different sizes and they're offset, you can't put the connector in backwards by accident. So you don't have to worry about that. But that's generally everything you need. We do need name, so let's do the name thing again. So here's the name. I'm going to add the text for the name. Change the layer to T names, so it's in the correct layer. And then again, on names, I like it to be 15% ratio, which is a fatter Silkscreen. 127 is a readable size in your PC board. So I'm gonna probably stick with the 127 size. That's the default for that. And then I usually put the name near pin 1, just as a reminder. Or you can do it here, like I do it on an edge like this. It's not a bad idea. But you're probably going to move it in your board once it's placed anyways. So just slap it down there. And then another embellishment I make is I want to know where pin 1 is on this thing, because that's the reference for the whole thing. Sometimes it's marked on the part, but I do like to put a pin 1 reference on chips and connectors like this. So I am going to go into a polygon layer, and you can do this as a dot or an arrow, and I think arrows look pretty sometimes. So your one option is this. So you do a circle with a width of 0, and then you could just draw a dot like right here, like that. And then so you could do this. So that just tells you when you're putting the board together, hey, pin 1's here, or you're debugging the board, where does pin 1 start? That's acceptable. I like to pump it up, step it up, kick it up a notch. What do the cooks on the cooking channels tell me? Kick it up, or bam, or something. So let's delete this. Let's do a polygon, and instead I'm going to do this little arrow thing. Let's go into the right mode here. So I have this freeform line. So I do this little arrowhead. So there. So that's kind of cool looking. So I'm going to stick with that. So we have name, and then the other thing we want to do is the value. Oh, you know what? I bet this went into the wrong layer. So you got to mine this stuff. Yeah, I put this on the names layer. That goes on the values layer. Sorry, it goes on the Silk T place layer. P feet layer. Make sure they all change. Yeah, it changed the shape. Okay, so yeah, make sure you put these markings. Eagle makes them all in white or gray layers, and it's hard to tell the difference, but that's why sometimes I change the colors of things so I know if I'm in the wrong layer or not. But names, go in the names layer. And that makes a difference if you're going to panelize the board or whatever, because there's scripts that take your name and preserve the name and rename the name if you're panelizing, and so it needs to be in that layer, or you're not going to get that proper change. And then things like little shapes that you draw, like this marker, that needs to be in your placement layer, because that's where all the other Silkscreen goes. It all ends up in the Silkscreen layer at the end, but scripts that process your part are looking for certain things in certain layers, and will process them or not process them. So you don't want to be haphazard about that. And you kind of want to, before you save this, is go back through things and make sure that things got into the layer you think they need to be. Have a little checklist or something. So the last thing I'm going to do is usually optional, but value. And I have used this in like assembly documentation where I've printed the values in a picture of the board, and the person assembling it now has the part number or the value that needs to go in that part in a drawing on their desk while they're soldering, or if it's me. But it's helpful to have this information. So I'm doing value, and I'm going to change the layer to T values, and then I'm going to change its size smaller than name, because it doesn't need to be big like that. So we're going to change this to about half of what the other one is, so like 0.6. And then I'm going to change its ratio down so that it's not bold. Oops.
Noodle says, what if you want the bold ratio?
No, Noodle.
He says, yes.
So, and then since I have space in the middle of this slot, I'm not gonna put it in the center because it'll make it hard to like position the part. The thing won't know what I'm grabbing. So I usually put this off to the side here, like here, there. So now you have the part. So if I go and manipulate layers now, like let's say I turn off the document layers, which you usually don't see. Now that's the actual, this is the part. It's the silkscreen, it's the pads, it's the mounting holes, and those two things. I can turn off the drill. Let's turn off the drill layer. Or the holes. There we go. So that's kind of what it's going to look like on the board. So, and then I have my double check my pin numbers. It's odd pins on this side and sequential, and even pins on this side, sequential. It all looks good. The only thing I notice here is the silk screen. Yeah, that'll be all right. The stop layers are overlapping, and that's just because it's a fine pitch connector. It shouldn't be a problem.
Very big.
But fine pitch connectors tend to solder bridge really easy, so you just have to be careful. Okay, I think I'm done with there. So now we're going to create the device. We're going to take the symbol we made earlier and this, and we're going to couple them together into a part that Sarah can use in her board. So I'm going to go back to here to my library, my top level. This little icon that looks like a book is all the parts that are in this noodle library. And then we're going to create a new device now. Add device. We're going to do card edge 50. So card edge. I'm going to change the description to card edge 50 pin. And I'm going to add the symbol that we made, which is the card edge 50. I'm going to kind of center it here. There's that. And then I'm going to make a new variant. I'm going to add this local package that I just made. And it is this Amphenol cool edge. And this can be called, I think, we'll just call it, I think we're only making one part, but if you had a 50 pin connector and you had like a surface mount and a through hole one and whatever, you can make different variants in one library part. So we only have one of these. I'll just call it, I'm going to call it SMT or dash SMT. And so I know it's a surface mount. Maybe there's a through hole version or something, but got to name it something, right? So there's that. Prefix for connectors is usually J is a connector. I don't know where that comes from, but it's always been J, but you can make the prefix anything you want. We can call it card. I think that would be cool. And then you can always change it in your design. So, and then value is, does it print that value thing, that little greater than value? Will it print in the part? And you say, you turn it on because yes, you want the value to show up. There's parts where you don't want the value amount to show up, so you leave it suppressed. So, and then in here, sorry, we already did that. We're going to connect it now. And this little yellow icon up here means you have not connected it yet. So that's the step you need to do here. So here's our pad and our connector. So on the left we have our connector, which gives us this cryptic G $1.1.2. Whatever. And that's just what they call it. I wouldn't worry about it. And then on the right is the actual pad of the footprint. And because we're consistent and we named them one to one, we didn't create like a name versus a number. They're number versus number. They're all there. And then the only pins we don't use is the mount pins because they don't need to be hooked to anything. They're just soldered to the board. So if we have one selected here and one selected here and we just do connect, we can just keep hitting connect and they should all, if you see on the right, they all line up. If they don't, then you need to back up and start over. And then we don't connect those. So it's connected. It's happy and connected. We're going to save our library. And I think we can test this out. So now we have this library. So let's go into Eagle, and let's do a new schematic. And in this schematic, we're going to add this part we just made. And we're going to go down to the noodle feet. I think it's called noodle feet library. Noodle 2019 parts. We just made this card edge right here. Our description came through. So there's a preview of the connector we just made. So we're going to say, okay, I'm adding this into this design right there. That's what it's going to look like in the schematic. And then let's pop over to the board. And there is our demo board with a sample part. And then you can do this. So here is the connector. Let's, for grins, let's reduce the board size here. So let's say this was our hypothetical board that we just made. I don't think I want to save this. So a nice feature in Fusion is you can see what the board's going to look like if you manufactured it using this manufacturing tab. So it takes that board you just made, and if I went to Osh Park or whatever and had this board made, that's what it would look like. And so from everything I'm seeing, it looks like what I thought it should look like. I have my gold pins, I have my edges to solder down, my silk screen is here, my arrow pin ended up here. So I'm going to say that this is a good part, and we can start using it for the thing.
Google says,
so there.
You should talk to your friends.
All right, so here's the other thing. So Sarah still uses Eagle 7, and I use Eagle 9, or use Eagle 6. No, I use 7, usually 7. So Eagle 9 is the online version. It's all the fancy 3D export, blah, blah, blah. So Sarah uses an older version because that version still lets you make squiggle traces, which Autodesk removed from the newer Eagle. And that was a trick where you could hold down, I think, the command key or option key and drag traces, and it would make them into spaghetti traces. And because Sarah's an artist, she likes to make boards that have crazy brain stem looking stuff. The new Eagle doesn't do that, so she refuses to use Eagle. I hope you guys are listening, until you get squiggle traces back. So there. So Sarah needs to use this library I made in Eagle 9 in Eagle 7, and they've made changes to the library. So how are we going to do this? So let's get rid of this. No, don't save it. Okay, and don't save this. All right, so I have this library that I made for Sarah. So if you go into your control panel, you have your parts library. If you right click in here, no, if you don't right click, if you go into file, and I think it's well, where is it? All right, there's a way to export. Oh, that's right, you have to edit. So edit the file, and now when you're in the library edit mode, when you're at the top level of your library, you can save a copy for Eagle 7.x. And so that lets Sarah, who's still using Eagle 7, use this library. And it basically strips out the references to 3D packages and anything that was changed in between versions. It just removes that extra information and makes a version that'll load into Eagle 7. And so she'll be able to use the footprint, but she won't get any of the new 3D features or anything that's in the newer Eagle. So you would do that, and you just pop it up, and you can name it and save it as an LBR file, and then you can go use it in Eagle 7. So I will do that for Sarah, and she will add that into her L-shaped board and do that. So that concludes the stream. I think we're done here. Right?
You should talk to your friends in the chat.
Do I have some chats?
You should look at.
All right, I'm gonna pop over to chat real quick. What do we got here? Roboheme is stop eating your cat. G stands for Gargamel. Thanks, Nikuma.
Ha.
Ha! I knew it. So, I hope the two of you enjoyed this stream. So there. I'm ending the stream.
You did it.
I didn't get the
I'm so
500
proud of
people I
you.
thought would watch me do this.
You have to keep doing it.
So I'm gonna go put in a laminate floor in my master bedroom now.
No, you're not. You're gonna have a beer with me.
After a beer,
There you
because
go.
everything's better when you're buzzed.
Yes, it's Friday. You get a beer.
Yeah.
Woo!
All right, people.
I love you.
There's something got in my eye, so I'm like,
Oh, you're just.
I'm gonna cry on screen.
You're just excited because Noodle's getting his new head.
It's like I had a baby. It's like there's like push mark, push that footprint out.
Yeah.
Yeah.
Noodle's gonna have an N64 brain. It's gonna be a cartridge.
Yes, Noodle's gonna have a cartridge brain.
Yeah, slap that.
He's going retro.
Yeah. Mommy can blow on his pins and shove his
Whoa,
brain.
I don't want to know.
In his head.
So.
Different versions. I can like make little label stickers that say like Noodle Adolescent 1.0 and then Noodle Adolescent
Perfect.
2.0 and then
Duck Hunt.
Duck Hunt. Oh no, Noodle, no. No, not Duck Hunt. No.
Super Mario Kart. .1.
He's just stomping on mushrooms.
Super
in the
Mario.
backyard.
Super Noodle Kart.
He's stomping on mushrooms in the backyard.
Yes, Mushroom Stomper. That should just be a game. Mushroom
No,
Stomper.
it's Super Mario. You jump on mushrooms.
Okay.
You go boing,
Yeah.
boing, and pipes. He's gonna find all the tubes.
All right. Thanks for whoever viewed. Thank you. I appreciate watching me. This will be up on YouTube anyways for people to watch in the future and give me a thumbs down, because why did this guy take an hour to make such a simple part? Yeah, he doesn't know what he's doing. He can't even add two numbers together. So have a good weekend, everybody, and we'll see you in the next stream. Adios.